What's up, guys? We're going to be talking about loops in programming. Very often we associate loops with iterables, such as arrays. And many programming languages have built-in methods for iterating or looping through an iterable, such as an array. However, we don't actually need an iterable in order to set up some type of loop in a programming language. Let's see an example in JavaScript. One of the simplest examples of this is to set up what's known as a while loop. And just have a look at the basic syntax. We'll have while, in brackets we'll have some type of condition to be evaluated. And provided that condition evaluates to true, the code will include, in this code block here, will be continually run until we get to a point where the condition in the regular brackets does not evaluate to true, at which point we'll move on with the next part of the code. Now we have to be a little bit careful when making use of loops in a programming language, because if we handle loops incorrectly, we can end up with what's known as an infinite loop. So I'll give you an example of this. If we simply say while true, now the problem is this is always going to evaluate to true. It's never going to change. The idea is that as we repeatedly execute the code in the code block, at some point, that code should cause the evaluation of this Boolean expression in these brackets to evaluate to false, at which point the loop is exited. So if we just simply have console log hello world here, this is an example of an infinite loop. Let's just run this for fun. Let's see what happens. So this is still executing. You might not be able to tell that, but it's still printing out hello world. This is because we are in an infinite loop. Generally, infinite loops are bad. Our code essentially gets stuck and it cannot continue past the infinite loop. And we can see we actually error out in the end, which is what's going to happen a lot of the time. Alternatively, we can manually stop the script. So aside from some very specific situations, we do not want infinite loops in our code. So what we can do is make use of an iterator, and very often in JavaScript you'll see this assigned to the variable I. So we'll say let I equals 0, and then we'll say while I is less than a certain value. So let's say while I is less than 10,000, we'll console log out the value of I in each block of code. We'll then say I equals I plus 1. So every time this block of code gets run, the value of I gets incremented by 1. So what this code will do is log out the value of I from 0 all the way to 9,999. Let's run this code. Let's see how long it takes. So you can hopefully see how blindingly fast that was. So just to be clear in the order of how this works, the script looks at the value of I, sees it's 0, so the expression I is smaller than 10,000 evaluates to true. So we console log out the value of I, then we increment I by 1, so that I is now 1. It's gone from 0 to 1. Then the loop of code repeats. So the script then says, okay, I is now 1. Is 1 smaller than 10,000? Yes. It then console logs out 1. It then increments I. And it will keep doing that until it gets to the point where I is not smaller than 10,000 anymore, because in our last run through this loop, I will be 10,000. So this expression will evaluate to false. We then break out of this block of code and carry on with the normal order of operations. So this is the basics of a looping program in JavaScript, but we can make use of while loops in a wide range of different languages, and the syntax is often fairly similar to this. We have while, we have some kind of condition, we then have a code block that's executed while that condition continues to be true. So for a bit of fun, let's change our script to 100,000 now. See how long this takes. Well, it took an extra couple of seconds, but you can see every single number has been echoed to the screen from 0 to 99,999. I'd really hate to think about how many times we must have console logged out hello world in those 30 or so seconds that we had that infinite loop script running. Now let's make this do something slightly more interesting. Let's define a variable myString, and we'll give it the value myString. In other words, the name of the string is the same as the variable name, which is completely fine. And one of the interesting things about strings is that they actually behave like arrays in some contexts. So instead of console logging out I could actually console log out my string at the index of I. Now, just to demonstrate that, let's just temporarily comment out this block of code here. So we have let my string equals my string. We could console log my string at the index of 0. Let's see what happens when we run this. So we just get M, because at index 0, which is the first position of the string, we have M. If we were to console log out my string at index 1, we'd get Y, because it's the second or first index character of the string. Now, just looking at our code block here, we obviously don't want while I is smaller than 100,000, because there's only so many characters in the string. Well, you possibly remember the array.length method that we can call on arrays. We can also call that on strings. So if I console log out my string.length, let's see what we get. In fact, it's a property, and we can see 8. So it's telling us that there are 8 characters in the string. So let's return now to our loop. Let's uncomment our code here. So instead of while I is smaller than 100,000, what we actually want is while I is smaller than my string.length. Because remember, with 8 characters in the string, that means we actually want to go up to index 7. So that's why we say while I is smaller than my string.length. Because if I is index 8, it means it's the 9th character of the string, and our string only has 8 characters, so we're going to get an undefined return from our code, which we don't want. So we say while I is smaller than my string.length, console log my string at index I, and then we increment I. Now let's just focus on this expression very briefly, I equals I plus 1. We are incrementing the value of I, but there are better ways of doing this, slightly shorthand ways of writing this. Now, there's an intermediary form, which is still not the best way of doing this, but we can say I plus equals I. And you can use this as a shorthand for adding a value to another value as a math operation. So instead of saying I equals I plus 1, you can say I plus equals 1. This is the same as saying I equals I plus 1. So you can say I plus equals 1. That's going to increment the value of I by 1. But guess what? There's an even more efficient way of writing this, which is simply I plus plus, which increments the value by 1. So again, this is the same as fully writing out I equals I plus 1. And very often we just use this iterator plus plus to increment the value of a variable by 1. Okay. Let's run our script, let's see what we get. So let's get rid of these console logs actually, so we just have the output of the loop itself. And you can see we get my string printed out letter by letter. And if we wanted, we could actually pad the output here. I'd like to introduce you in JavaScript to the backtick. And this allows us to include variables inside a string. So we actually have 3 different similar characters. We have the single quote, we have the double quote, but we also have the backtick, which is different from both of the others. And this allows us to use what's known as a string literal. So we can say the character at position, and we use the $, curly brackets, and I. So we can say the character at position I is, and of course my string I is also a variable. So we use the $, and we'll wrap it in curly braces as well. And we of course need to now end this string literal with a backtick. That's the wrong place for the backtick though. It should go just before the closing bracket here. Okay, let's run this. So you can see we get the character position 0 is M, the character position 1 is Y. Now, of course, this references the index. Maybe we don't want that. We can actually include a JavaScript expression here. So we could say the character position I plus 1. That way we're using a system based on 1 being the first character, rather than index 0. So you get the character position 1 is M, the character position 2 is Y. So keep in mind this backtick character can be used to create expressions like the one we see as follows. Otherwise, if we weren't going to use the backticks here, we'd have to do something like the character at position. We'd have to terminate the string. Let's just make sure it starts with a single quote. We terminate the string, then we'd have to say plus, then we'd have to include I, then we'd have to include plus, then we'd have to pick up our string again, etc. and say is, then we'd have to terminate our string, then we'd have to include my string at index I. So you can see it's a lot of extra work compared to just using a string literal. Of course, we're missing some spaces there. So we've got the character position 0 is, so we run that. There we go, get the same output, but we're using concatenation to generate the string in this case. So let's go back to what we had previously with the backticks. We're now going to see a very similar but slightly different way of using a loop, and that is going to be the for loop. So let's comment out this code for now. We'll keep our string and our iterator. Now, for loops follow a very specific formula. And again, this is the same in many other coding languages as well. So we say for, and we have to specify 3 values in the brackets here. So we specify a starting value for I. And you'll see that all of the elements of our while loop we're actually going to incorporate directly into the for loop. So it's basically a more inclusive way of performing the same action. So we initialize our incrementer, which is I. So we say for I equals 0. And sometimes you see this without the spaces. It doesn't matter too much. You often see it like this just to be condensed, but it really doesn't make a difference. We'll end this with a semicolon, so it's a complete expression. We'll say for I equals 0. We then specify the while part of this. So we want this to keep running while I is smaller than my string.length. Okay, so we recognize that from our previous loop. We'll end this expression. Now we need a third statement here, and it's going to be the increment. So we don't always have to increment I by 1. In most cases, we do increment I by 1, but we could increment I by 2 or by 10 or some kind of other formula for incrementing I. But in this case, we can just pass I++ to increment the value of I by 1. And let's take our code here. We just need this one line now because everything else has been defined. So we'll just paste this line of code in here. We don't need to initialize I anymore because it's included. We do need to declare the myString variable and assign a value. Now this should work in exactly the same way. So let's just run this. You can see we get the same result. So just remember, for the for loop, we initialize our incrementer. We say the while part of this. So how long should it increment for while I is still smaller than my string.length. And then we include the incrementer I++. So same thing, but a slightly different syntax here. Now these are not the only loop structures that you run into, but they are 2 of the most common. So we've looked at the while loop. We've also looked at the for loop.